So let's recap a machine learning cycle, and will be like intro to what actually Vertex AI provides us in scope of developing a machine learning solution. If we have machine learning models, we mostly start with a business goal. We define why we need this machine learning model. Then we frame the machine learning problem. So what will be the input data, what will be the output data. And then we process the data, we prepare it somehow. We either do it in a simple way, or we develop some pipelines, airflows, etc. Then we develop our model, our standard research part in Jupyter Notebooks or whatever. In any place you like to do that, and then we come to deployment and monitoring. And from my experience, mostly machine learning engineers are actually good in at all of the parts of machine learning lifecycle, but to deploy our machine learning model, we need to have some infrastructure. We need to we mostly deploy our machine learning model as an endpoint, and we need some server where this endpoint will run, and we and this part of organizing the server is not the most pleasant one. Might be, especially in the infrastructure which already exists of our in our company where we work, also which is around this machine learning model lifecycle is our actually repeated training of machine learning model and evaluating and everything. We mostly have a quite complex procedure for data collection, for model training, for model evaluation, and etc. And like the most modern way to do that is to do every step in a Docker container, because we will have different environments for each part of this model lifecycle, and to organize all this process with different Docker containers for each part of machine learning model lifecycle, and to schedule that and to make all this work, we need some orchestrator which leads us to usage of Kubernetes. And here most of engineers start to be upset, because Kubernetes is quite a hard tool. It's big, it's complex, and someone investigates time in exploring Kubernetes, but from my experience, I also passed one course on Kubernetes. I passed the course, and then when I tried to use it, it was much more complex than passing the course. So it is sometimes really helpful when we don't need to care much about the infrastructure as machine learning engineers, or, for example, as business representatives who just want to plug in some machine learning to their solutions, to use it in their software which this business is developing. So for these purposes, such solutions as Vertex AI exist. And currently, we will talk more about Vertex AI. So what is Vertex AI? Vertex AI is a machine learning platform within Google Cloud Platform. So Google Cloud Platform, it has a lot of different parts, and Vertex AI is like a set of tools for working with exactly machine learning tasks. And Vertex AI allows us to train and deploy machine learning models and AI applications. So Vertex AI combines data engineering, data science, and machine learning engineer workflows, and enables machine learning teams to collaborate using the common toolset. What does it mean to use the common toolset? It means that if we have a couple, let's say a team of 5 data scientists, all of them will work in the same fashion. So they use Jupyter Lab, for example. On Vertex AI also they have Jupyter Lab. You can easily establish it, so that you have different machines with different amount of resources, and you can develop either easy models or very complex models which require some GPU machines and need to process terabytes of data. And you don't have the situation where you have 5 data scientists, each of them is working locally with their own local environment and deploy models in their own fashion. They deploy them with different libraries for endpoint organization, and so everything is different. And when you try to connect it all into one big picture, it might be complex. So mostly in this case, we hire a machine learning team lead who tries to make things clean and organize the processes. So Vertex AI, one of the features which it provides is that processes become clear. So we develop the model in actually Jupyter Notebook, or we can do it in let's say we can just describe each of parts of our ML solution in a Python file. We upload it to run on a Docker container, etc., etc. We'll in a couple of minutes, like not in a couple, but first in the lecture we will talk in more details about those parts. And in Vertex AI, there are several options of model training. One of the options is AutoML. What is AutoML? It's when we just upload our data. It might be tabular, image, text, or video data. But we don't write any code. We just work in user interface, like graphical one, and we upload, for example, tabular data, and we have our users, and we need to classify them into fraud and non-fraud. And very, very smart algorithm in our cloud provider resolves this task for us, and sometimes it provides us the final model. Sometimes it provides us also only the endpoint, depends on which tool we are using, but the result of this process is that we have a working model without necessity to write any code. The advantages of such solutions like AutoML is that you don't need to know a lot about machine learning research. You need to only have data, but the disadvantages is that it's not very flexible, and if you need to do something very in a special way as you want it to be, if you want to process data in some special way because you're a domain expert and you want to contribute your domain expertise into the data process and before you pass it into the model, and you definitely cannot use your own model with AutoML solution, then it's not what we use. So mostly AutoML might be popular for people who are not machine learning engineers, but just some business people who are okay with reading a couple of Medium articles and figuring out how to work with the cloud platform. Another possibility how we can train a model on Vertex AI is custom training, and that is exactly what we will do today, because our lecture is quite technical, and my aim is to provide you an observation on how to build a working pipeline in Google Cloud, and that will be with custom training. This provides you a complete control over all training process. You can use your preferred machine learning framework, you can write your own code, you can choose hyperparameter tuning options. You can actually, with Vertex AI, you can you can customize on every level of detail. So you can only write the code of model training, or you can write it in your custom Docker container, or you can even you can even split your code in several files and create a complex part for model training or model preprocessing, and then wrap up everything in your, again, custom container, and just upload it from a YAML file, just the configuration of the component which you are going to use. So we are like we can use some parts pre-built. For example, there are some containers which are already built, for example, for TensorFlow solutions, for scikit-learn solutions, and we don't need to create something on our own. Or if we have very special libraries which we use in our solution, or special requirements for our model, we can do everything more, in a more custom way. Same with deployment, so we can deploy either with just one, with call of one like class for deployment and specify all the input parameters it requires, or we can create deployment our own, creating an HTTP server and creating a Docker and providing the exact Docker in which we want to deploy our model. In case again we are using some libraries which are not present in some popular and open Docker containers in registries. So advantages of custom training is flexibility. Disadvantages that you need to have a lot of expertise in how to train machine learning model, how to do every part of machine learning solution, and that is actually quite a lot. Vertex AI is convenient because it provides infrastructure to support the full cycle of our ML models. As I told, we don't need to care about how to orchestrate our Dockers, that we need to rise our Docker when we start training model, and we need to switch it off when we finished our training because it uses GPU and it costs like millions for us to have this Docker container running like forever. So there is a problem when we are using cloud providers that we need to pay for anything we do, and if we are using some big computational resources like graphical processing units, some powerful ones, then they cost really a lot per hour, and we cannot mostly businesses cannot afford having those machines always running during like days and nights, like 24 hours per day, 7 days per week. So we need to like good solution for machine learning tasks looks in a way that we have our pipeline, we have data collection, model training, evaluation, and let's say deployment, and each part is executed in separate Docker, and the process starts to execute this part gets executed, and then the process finished with turning off all the resources which we use for performing this exact part of our machine learning solution development. Yeah, so you can definitely find a lot more about Vertex AI in official documentation. It's quite huge, and we'll currently review what actually Vertex AI provides to us. So those are available parts of Vertex AI. We need to read it like from the top to bottom. So it has tools for data preparation, feature engineering, hyperparameter tuning, model serving, and even model explanations for edge deployment, for model monitoring, and for model management. And this is what AutoML covers. So we can develop AutoML models for like different input data input types, like video, images, some texts, or just tabular data. I currently work with like tabular data, but they have links to images which I also process, and they have product descriptions which I also need to process. So for this reason, I mostly write some custom code for processing every part of my data, and definitely don't use AutoML, but it might be useful for you. For this reason, I am talking about it. So Vertex AI even has data labeling, and sometimes it might be helpful if you don't have some company with which you label the data. It has feature store. What is feature store? It's when For example, we have our development. We have a couple of researchers who work on, let's say, on same in the same direction. Let's say fraud detection, and we need to store our data between experiments and also to share it between researchers, because they might create some useful features which might be very helpful to resolving not only the task of researcher A, but for resolving the task of researcher B and C. And that is what feature store is used for. So that's for storing data sets between experiments so that our experiments were reproducible, which is quite important in machine learning development, machine learning models development. So Vertex AI has model training with hyperparameter tuning, and hyperparameter tuning they have with some bias optimization, and actually it finds quite good hyperparameters. I tested it. Also, it has parts for prediction. We can perform batch prediction, so that the general batch prediction when we provide a batch size and we just get predictions from an endpoint which we created or from a model directly. And we can also have online prediction when we actually, for example, we have a site and we need to provide product recommendations in our marketplace. In this case, we definitely need a online prediction, because our user won't wait half of a day for our machine learning model to provide all the predictions and us to serve those predictions to our users. So online prediction is quite expensive, but there is such a possibility to at least, for example, if you want to test some new model and not to get very busy with everything around model deployment and having it in real time performance. So Vertex AI provides a solution to speedy experiments with that, I would say. It has model monitoring, so we can monitor our model performance during the time. Metadata storage, so sometimes we need to store our data regarding the model. So which hyperparameters we used, which actually model we used, and probably some custom information about the data set or anything we actually want. So we can store this metadata. We can store data sets, but actually I didn't use that a lot in my work. I mostly store all the data sets in Google Cloud Storage. Actually, that's like S3 in AWS, just ordinary storage like Google Drive, I would say. It has experiments, and in experiments we can compare the experiments between themselves. So we can have like for each task experiment, and it has its parameters, let's say the model name, the performance metric 1, performance metric 2, and like speed of training. And we run a couple of experiments, we record everything in a proper way, and it gets recorded into Vertex AI, and then you can visualize and compare your model runs and select the best model and understand actually in which direction you need to move to improve your model. And all of that can be connected in pipeline. So pipeline is a big thing which contains several parts of machine learning solution, and it's the advantage of having pipeline in compared to having like separate parts, because we always can separately process the data, upload the data into some storage, then download the data from storage and train a model on this data, and then upload the model into the storage, and then take this model and deploy it somewhere with some more coherence and some more functional. But if we have everything in pipeline, everything is like compiled together, and this is like one solid part which we can which we can, for example, automate to run like on a needed schedule, let's say once a week or once a day or whatever. And also Vertex AI has a deep learning environment and notebooks like in Jupyter Lab, so the same as you can have locally. It actually provides you in cloud, and the advantage of that is that if locally you have some limited RAM, then in Vertex AI you can have much more RAM, some GPU which you need, and the Jupyter Lab environment which you are used to. Let me know if you have any questions so far, because I think that I'm moving quite fast, so I need to be sure that we are aligned here with you guys. In the meanwhile, we are reaching a Vertex AI interface, and I will show you some how it looks. Let me exit the presentation, and let's get here. So I'm currently in Google Cloud, and actually for our workshop part where we will practice, if you want to practice with me, then you need to activate your Google Cloud. It's very easy. When you just log in into your Google account, I actually created this Google Cloud account when I created the presentation exactly for workshop to go through all the steps which you will need to go when you are setting up your first Google Cloud account and your first project. So when you are entering at first time to Google Cloud, there will be a like banner. Let me check. Probably I will have it in some of my accounts, and to show you what I mean. Here I also no, it's not. So you will have a banner which will tell you that they propose you to use $300 of free credits. You just press a button that you agree on that, and then you need to provide credit card details, but they won't charge you until you have those $300 free credits. And actually they then will turn off your payment service after those free credits are will be like deactivated in a year if you didn't use it. So that's really a nice opportunity to test some Google Cloud Platform functionality and find out whether it's comfortable for you to use it or not, etc. So for our purpose of trying Vertex AI, it's like it's more than enough. Like those $300, you can create a new Google account, for example, if you already used your credits on your main account. For example, I use an account which I don't use much, so I applied for a new pack of $300 credits. And after you filled everything, you will have my first project. It's a standard one which is created for each new user, and you will have project ID. You need to save it somewhere because we will use it in our Vertex AI pipeline, and actually for login part, because we need to authorize it, and our authorization is always project bound, so we can authorize in different projects. And then here, when we are authorized in our Google Cloud and it's running, so we can enter in the search part Vertex AI, and we can see that there are several products, but we need the main one. Like it's an umbrella on around all of the products. Here it's you need to be very attentive because we can have different regions, and actually our solution which we are going to develop today is in Europe West 1. this is one. So you need, as you can see, when I changed, we can see that I have some information here because I did something here, but on the previous region I didn't have anything because I didn't run there anything. And what do we have here in Vertex AI? We have dashboard. It's like some main information which you need to know, some recent endpoints with requests. Then we have data sets, and actually they used to it's Vertex AI says that it's a convenient way to share datasets between experiments, but actually for me it's much easier just to upload all the data into Google Cloud Platform and reach this data from there. So I don't use this part. Feature store, which I don't also use much. Labeling task, that's in case you want to label some data. You need to specify all the details about labeling, etc. And there is a pricing available on Google Cloud Platform site, so you can find out how it will cost. Then we have Workbench, and Workbench is a place where you can create some Jupyter Lab instances, and I here already created one for demo. It's really easy. So what is Jupyter Lab instance? That's a machine. As you can see, that's a machine with TensorFlow 2.8 environment. That's like a standard one because we are working in Google Cloud Platform. TensorFlow is development by Google, and we can specify a machine type. I used the most basic machine type, whether we need GPUs and like owner and also a zone. So if we enter into the Jupyter Lab, we can have here like a file system. We can create here notebooks. We can write code in here. Currently, it probably will be starting for some time. So, it started quite quickly. So you can also have here tutorials. That's something which is created here like by default. So in each instance of Jupyter Lab created in Workbench, you will have those tutorials, and they're quite helpful because sometimes, for example, you have here Vertex examples, and you have really a lot of the examples, and you can open them and try to and go through them, and everything will be in here. Everything is the more as easy as it could be. So we will work with you in Google Colab because having those Jupyter Labs is also something which you need to pay for because you have a running machine type. It can get like idled, so if you don't use it, but still, so if you created Jupyter Lab and you work there, then it's better to download all your files into some GitHub, and then turn off the Jupyter Lab for if costs matter for you. In my case, in the company where I work, we mostly don't turn off the Jupyter Labs, and it's like my working machine. So I work mostly in Jupyter Lab because it's I have all the authorizations here. It understands that that's me, Hanna, and I have such permissions, and I can do such things. You can work here same as you work in your local Jupyter Lab, and you can upload here data. You even can have like that's how to manage the notebooks which are opened. You can shut down all, for example. You also have here a possibility to like some visual version control, and you can run a terminal here. So quite convenient thing, especially if you need to run some experiments on a big machine with GPUs. So you just create with new instance, and you create some machine of the type which you need. So everything is very easy, and it becomes ready like in a couple of minutes. So you can choose here whatever you want. I showed that just for your information because I find that it's quite a useful thing. So actually, the example which we are going to do, you can clone the repository in the instance of Jupyter Lab and work there, or you can just open it in Google Colab. Google Colab is an open tool for everyone, which you can reach if you have Google account. And the only drawback is that it has 20 hours session limitation. So if it's up more than 20 hours, then it will stop the session, and you will need to rerun on the notebook from the very beginning. But if you just sat and started to work and ended it in like 3 hours, like you will have everything in your Google Colab. Okay, what we also have here, we have pipelines, and I already have here. Again, I need to change the location. Europe 1. I already have here one pipeline which I ran during my latest test of everything. I really hope that everything will work because this demo effect sometimes causes problems. So I already have one successful run of pipeline, but we will run one more with you. And here you can review all the pipelines you ran, and they will be visualized in such a beautiful way. I really enjoyed it. It's a like graph, and you can review all the parts. They have some parameters. You can find out a lot actually about the pipeline by reviewing the visualization, and it's so like good looking. I really like it. It's clean and understandable. Also, you can reach logs, for example, from here. So everything is like in one place, and you can go to exact job by clicking view job and review some more details about the exact job if you want to debug it. We have a question. Does Google Cloud provide a flexible plan for Vertex AI? Flexible is when you have some budget and it will stop to charge you when Google Cloud will reach the predefinable budget limit. Great question. To be honest, I'm not very acknowledged about the pricing part because my manager told me not to care about pricing. That's because we don't mostly train models with GPU. That's enough for us to use CPUs, and it makes our development quite cheap. You can there is a big list of all the pricings in the documentation of Vertex AI, and you can review it here. Everything is clear, but you need to compare the prices for machines with the standard prices. And from what I observed, when mostly you work for what you pay for what you use. For example, if you train a model, you just pay for the time during which the model was trained. For example, it was like 12 minutes. So you pay only for the machine on which your model was trained for 20 minutes of time. But for example, for this Jupyter Lab, there is something more complex because we don't always use this Jupyter Lab. Sometimes notebooks are idle. So there is another pricing. There is a lot of information about pricing on this page. So I really encourage you to examine it because I'm not the guy the girl who will tell you much about the pricing, unfortunately. Yeah, and also from the general part of like budget usage in cloud providers, mostly you can set up a limit for like all of the costs. When you, for example, have your access to your payments, you mostly can set up limit. For example, notify me when my costs reach either this amount during the month, let's say $2,000 during the last, let's say 30 days, or if your if your expenses reach, let's say 90% or some other percentage of the amount you specify. So that you could do something before you will get out of the budget. So yeah, that's a really important part to manage the costs. But at my current workplace, we don't care about that much, because we have some allocated amount for our work, and we mostly don't get out of it a lot. What else? We reached our pipelines. We will come back here after we create actually our new pipeline with which we will work. We also have trainings, and currently I don't have here trainings, but we will have one after we run experiments. We have experiments. We won't create experiments, but experiments is when we want to compare different experiments with different data, for example, with different data processing procedures, with different amount of data, but with the same model, let's say, or in any aggregation of experiment idea which you want, let's say, for some client, for some data, for some model type, etc. We have model registry, and we have currently here one model which I trained before the training, but we'll train same one with you. And here, like, it's models which are uploaded from the it's a part before deployment, so we need to upload a model to model registry in Vertex AI, and then we can create an endpoint. So it's like a required part. And we have endpoints. Endpoints is like it's a part to which we can create a request and just general REST API and get some let's say model predictions because we are working with machine learning models. And here we can always get some help regarding how to create those requests, but we will create a request with you in Jupyter Notebook. So we will create an endpoint, and then we will test it with creating requests from our Jupyter Notebook in Google Colab, and actually we will see that our endpoint is working, and we did a good job. And a couple of more parts. Batch predictions is when we, for example, have a data set. I decided not to show this part. I tested it, and it took too much time. But I have code in the Jupyter Notebook how to run batch prediction. At my current job, I also have quite problems with running batch prediction. But actually, this is done for when you, for example, have a test dataset, and you want to run your model through all the instances in this dataset. In this case, batch prediction might be helpful. So you just set up a job which will run your model through all of the instances in your dataset and generate you a final result, and then you can analyze the results. We have also metadata, and all the metadata is stored here, like models, datasets, metrics, and some other artifacts like endpoints. So there is not much now, but actually this could be quite. So during your work with Vertex AI, the number of metadata grows, and this is actually quite. It's just a link to something which is stored in Google Cloud Storage, so you can right away go to the place where this metadata is stored. Just you need to be sure that you're in a right Google account. It seems to me that I am right, but it's not reachable. It's sometimes no, everything is fine. So we are seeing some evaluation, but we didn't record here anything. And matching engine. Never use that, so cannot say much about that. Yeah. So as you can see, Vertex AI has a lot a lot things, a lot parts, which allows us to do most of the tasks we need for working with machine learning models, and it's impossible to cover everything in one lecture. I really wanted to, but I decided that it would be better than if we cover like some main parts, and then you can explore after you understood how everything works. And to sum up, when Vertex AI is especially helpful, it's especially helpful if you don't have, for example, a DevOps team to organize infrastructure of your machine learning models lifecycle, but you need to deploy and automate your machine learning solutions. For example, you have machine learning engineers, but you don't have a DevOps team which will organize you Kubernetes with kubeflow and containers orchestrations. Also, if you, for example, don't have both machine learning and DevOps team, but you have a lot of enthusiasm and you need to explore machine learning solutions for your business or for your clients, and you're ready to get some new knowledge and find out how to implement machine learning solutions just by using graphical user interface, as I already showed you, like Vertex AI. So in Vertex AI, we can do everything either from code or from interface. So those things are interchangeable. For reproducibility, it's definitely better to use code. But even if a person doesn't have a coding experience, he or she still can use the solution. And we always can use HTML without coding. So also, Vertex AI is helpful when you don't have data engineering team, which will support all the data pipelines with like complex Airflow jobs and orchestration of them. Whereas you have a data scientist who wrote a huge script with data processing, and you just need to help him or her to deploy this script and to schedule its run, for example. So it will be helpful because in Vertex AI we can create just a component which will run in a separate container, and we don't need to do anything more. We just have our Python code, and we plug it into correct place, and everything works. Or, for example, if you need to quickly experiment with models training on cloud, for example, if you're on hackathon, or you just need to test a hypothesis during 1 or 2 weeks, or you are developing a POC for your client, then it's Vertex AI, I think that is also a good solution for you, because if you will start to develop all the infrastructure for for mature machine learning solutions, it can take you like months, years. Vertex AI allows to minimize the efforts in infrastructure setup. Why I personally like Vertex AI? It's because it's accessible, so the user interface is clean and intuitive, and it's really so. Even when I came and that was my first day with working with Vertex AI, I was like not very stressed. Also, Vertex AI brings together everything we need for working with machine learning models, and like everything is in one place, and you can reach all the parts of what you're working with, like data, separate jobs, logs, etc., from this place, from Vertex AI. But everything is gathered here. Also, as I already told, Vertex AI has multiple entry points, so you can develop the solutions either from code or from user interface, or combined. So and it is so it allows people with different level to use this tool and to benefit from it. Also, it has scalable infrastructure, so you can select any the machine type you need to the costs which you can afford for now, or to the tasks which you need to resolve, because tasks in machine learning may be very different from the required resources amount perspective. Here I remind you about free GCP credits, so that you were not afraid of that. Working with cloud will cause some costs. So you can apply on those credits after you just entered into Google Cloud from your ordinary Google account, and there will be such a message which will tell you that you will have 300 credits for 90 days. It was time, but it was when it was for a year, or probably I was a student. But I said previously that those credits are for a year, but they're actually for only 90 days. But still, you can do a lot. I remember that I was one who created DDoS attacks with those free credits on Russian sites. So I was very happy to spend them on some good thing. Currently, we reached the coding part. We are like approaching it, and I'm here sharing the GitHub account. I will also share it in chat. This is the GitHub account where you can find the notebook with which we are going to work. I decided to leave all the outputs in the notebook because it might be helpful for both for you and for me. You can right here press open in collab, or you can pull this notebook in the collab, which is quite more complex because you need to run git clone in your collab. And if you do that, you will open Google Collaboratory with my notebook. I currently have black theme because I like everything in black. It allows me to have my eyes less stressed. We will work with this notebook, like wine classification pipeline. But here is one more notebook, which contains a simple example of Vertex AI pipeline. It creates a simple pipeline. Let me show you that one. So it just has 3 components which interact, and I also left here all the parts of running so that you could review that. It might be helpful for you if you are completely new to those Vertex AI pipelines, and if with machine learning something won't work, you can run this and this should work because it's very simple and everything is more understandable here than in machine learning pipeline. For me, it's always helping when I am acquiring new tool. I'm like starting a new tool, and I want to run something working to like get dopamines and confidence that, well, something is working. I'm going in the right direction, and something more complex will also work for me. So this GitHub link, and we will work with wine classification pipeline IPython notebook, and we will work with it in Google Collaboratory, and I will tell you how to connect from Google Collaboratory to your Google Cloud platform and use all the resources we need to use from our cloud provider. So we reached the end-to-end pipeline part, and here we will talk about Kubeflow and Vertex AI. Kubeflow, if you don't know what is that, it's an open source platform for machine learning and MLOps. MLOps it's machine learning plus DevOps on Kubernetes, and it is a tool by Google, and it provides us a possibility to develop like components for different parts of machine learning solution, like model development, model trainings, model serving, and automated machine learning when we automate something on a specified schedule. And Kubeflow has pipelines, and pipelines is a platform for building and deploying portable and scalable machine learning workflows by using Docker containers. So Kubeflow, it's a tool for for machine learning solutions, which uses Kubernetes, which is Docker container orchestrator, and in Kubeflow we have pipelines, which actually it's a way how we can organize our machine learning solution steps with usage of Docker containers at each step. But we don't need to care about how do they start, how we will orchestrate everything. So we just describe the pipeline, we compile the pipeline, and everything works. And pipelines in Vertex AI are built using Kubeflow pipelines SDK. Actually, again, Google Cloud Platform is by Google, Kubeflow is also by Google, and they match perfectly. And actually, Vertex AI also Vertex AI pipelines also can be built with TensorFlow extended, but I didn't use it. I use only the pipelines which are built with Kubeflow pipelines, and that is more than enough for my job as a machine learning engineer. How to build a Kubeflow pipeline? So at high level, it consists of 4 steps. The first step is to create all the necessary components with Python Kubeflow pipelines SDK and some specific language. We can see the example. We'll observe the examples. There is, I think, that nothing very complex here, and you can after your own components, and here is a clickable link in presentation how you can do that, or specify some pre-built components for you. So pre-built components is not the same as pre-built Dockers, because Docker is just a machine or some part of this, like it might be a server, but mostly it's for me, mostly Docker is a machine on which I can run my training, for example, or etc. So it doesn't realize some server or something. So and pre-built component is actually the part of machine learning solution which already does something you need. For example, we can use AutoML as one of the components. For if we pre-process data in a custom way, we deploy our model in a custom way, but we want to use AutoML for the training part, so that to get a working model, if we don't want to develop some machine learning model. For example, if you have a data engineer in your team, but you don't have a machine learning engineer, so you don't and your data engineer is not very acknowledged with machine learning and all the specifics of research, and you have actually a quite complex machine learning task, but your data engineer can process your data, you can then use HTML component for model training and deploy this model for deployment. Then after all the components we need, we compile the pipeline, and it results in a static representation in YAML file. So everything is in YAML. So such a declarative way of specifying what we need to be done for our machines, on which this pipeline will be running. That's actually very Kubernetes way of specifying the things. And then, after our pipeline is compiled, we can run it with the specified backend. So we run our pipeline on some machine, like with GPU, without GPU, with some amount of CPU, etc. And Kubeflow pipelines backend orchestrates the Kubernetes pods creation. Kubernetes pods are like machines on which everything runs, and data passes, because we can pass our data between different components. For example, from data preparation to data training, we can pass like the data which we need. And then we can view all our runs and experiments with the Kubeflow pipeline dashboard. And actually, the thing which I showed you with pipelines, it's like a more fancy version of Kubeflow dashboard. So to sum up, Kubeflow pipelines are actually a backend for Vertex AI pipelines, and for this reason, if you're developing a Kubeflow pipeline, you need to like search for some information about components and pipelines, not in Vertex AI documentation, but in Kubeflow documentation. And that's actually not something I knew before I started to work with those tools. And it was very helpful when I found all the information in Kubeflow documentation. What is a Kubeflow component? So we talked already about Kubeflow pipelines, like something big which consists of components. And what is component? Component is a building block of our ML solution. It's a basic unit of execution logic. It's like a named template for how to run a container using an image and a command and arguments. What does it mean that it's a named template? When we create a pipeline, it's always something quite abstract. So it's not a thing which gets always the same the same version of data set and the same input parameters. It's something abstract, like when we create a function in Python. So in function we have arguments, and in pipeline we also have some arguments. And when we compile a pipeline, all its arguments will be connected when it runs. So at first it's just something which expects some parameters of specified types, but it's not already a working something. It's just a template. And same is for each component. So each component is a template in which we can pass different data, pass different arguments, and we can depending on this input, we can generate different output, and we can pass that output to further components. So component inputs are dynamic data used in either the container comments or arguments. And component outputs may be the machine learning artifacts, for example, data sets or model, or let's say just JSON serializable data, or like some file or whatever. But we can also always just dump everything into Google Cloud Platform and don't care about those outputs and some. But using them is more like more Kubeflow way of doing things. Each component runs in a separate Docker container, as I told already. It seems to me that 5 times. I hope that you will remember that each component in Vertex AI pipeline runs in a separate Docker, which you can specify, and you can either use your Docker image which you built, or you can use any image from Docker registry, from your local, like not local, company-wide registry, like private one, or from global registry, or from like Docker one, or from for example in GCP they have their own registry of most popular Docker images. And here on the right side of the slide, we have an example of Kubeflow component from our today's notebook. And this is the component for training. And we can look at it. And if you're a machine learning engineer or data scientist, you probably understand what this part of code. So that is actually what we do every day, probably when we are doing a research. We are calling scikit-learn, we are importing pandas, we are importing pickle, we read some data from some path, we create our model, we fit our model, and then we record some metadata that is for output and dump our model. So very, very basic things, but we have some specific doesn't have anything except for Python and Learn 1.0. And we have also some input parameters. We have data. We will talk in a minute. Our hands dirty, and we are moving to our our task. Actually, it's not very important which task we are resolving. We are most, as I already told you, we are most interested in the process, but we will use a wine quality data regarding wine and some features which describe the wine, and we will need to classify the wine into the best quality and not the best quality. Actually, this dataset is more for either multi-class classification or for regression, but I decided to simplify things and make it just a binary classification. So good wine or bad wine, that will be our task for today, to create a classifier. We will use standard random forest classifier, as you already seen on the previous slide, and you can, I encourage you to experiment and try, for example, XGBoost with for this classification, and compare, for example, the performance, and it will allow you to play with the code which I provided. Pipeline architecture. I already showed you it, but I will explain it once more in more details. So we will have 4 steps of our pipeline, and those are data preparation, train, evaluation, and deployment as an endpoint. And we can see those steps as a picture. So first, actually, names is something we can specify, and currently names are such which you can see. The first component is dedicated to data preparation. It generates, as you can see, some artifacts, and we then have model train. Then we have model evaluation. Why we have connection here and here? That's because for model evaluation, we need to use the test dataset, which is actually generated on data creation part. And we also need a model because we will run our trained model on a test dataset, and we will generate some artifacts which are just JSON files, which will be stored in Google Cloud storage, and we can review them, we can then process them, visualize in Data Studio, whatever we want. And also we have deployment part, and this is a conditional part. So we can specify argument whether we want to deploy this model or we don't want to deploy this model because we just experimenting and we don't want to deploy it. Okay, and as a bonus, we will also schedule our pipeline runs. So I will show you how to do that, and I think it's very crucial part of machine learning production development because all businesses currently want our models to provide some value and to work in production and to retrain every week. And it's not always clear how to organize it with some cron job or with some airflow or with something else. It depends on what you have in your company. So I will show you how to do that right here in Vertex AI. And also we will test our endpoint, like freshly created in action, and get predictions from it, because that's what we actually created that endpoint. So that is it, what I wanted to tell you about the task. And finally, no, we are not wrapping up yet. We are just starting our demo part. So, I reconnected, and I will probably switch to light view because I think that it will be easier for you to follow. Theme, and I need to use dark, and I will save, and yeah, everything we have. And I will probably have like change the scale so that you could see everything. Can you see the code well? Put some plus into the chat. I will be really happy to communicate with you. Thank you a lot. Here in our collab, Google Collab, I hope that most of you are acquainted with this tool. This is actually a Jupyter Notebook in cloud provided by Google, and you can create it from your your Google Drive. So if you get into Google Drive, you can press New, press More, and here will be Google Collaboratory. Or you can connect more apps and put here Collaboratory, and it will here it actually has and install this like plugin and it will be available for you, and then you can just use Google Collaboratory, those notebooks, as Google Docs or everything else you use in Google spreadsheets, etc. To open my notebook from the repository which I shared, the easiest way is to press, just as I showed you, like here when you enter the notebook, you can press the collab button, and it will it just contains a link to Google Collaboratory, and it will open it here. But you can also open it in another way. For example, we are going to File, and we want to open Notebook, and here in Google Collaboratory we can open notebooks from different locations. For example, we can just open examples, but currently we are working with my example, so we need to specify here our GitHub repository. Press enter, and the available Google Jupyter Notebooks will be button to you can go and run all the code. I already have my Jupyter Notebook open, and I have a table of contents open, so you can observe what we are going to do. We will install everything. It's a very important part, because without that nothing will work, because we need to authenticate, we need to set up global variables, we need to import the correct libraries. It will work, hopefully. Then we will create a pipeline consisting of our 4 components, and then we will like compile the pipeline, run the pipeline, schedule the pipeline, and get the predictions, and clean up is also clean up everything, so that you were not charged for usage of the resources of Google Cloud after you finish this workshop, if you don't want to proceed with this task. So I currently will close that, so that we had more space. And what we start with? We start with authentication. That's a very important step, because without that we just won't reach our resources in Google Cloud. So you need to do this step. You just run the we can see that it ran successfully. Great, in certain seconds. Then you need to specify your project name. And here I provided a screenshot on where to find this project name. To find the project name, we need to go to our Google platform, and currently I will move here so that it was more convenient to me to switch between tabs. Yeah. So we go here, like console cloud google.com, and here we press into our project, and we can see all our projects I have. But you always have at least one project if you have some payment plugged in, and you can get payment plugged in if you apply on those 300 credits. And we need this ID. So I have Tokyo charge something. It's like something automatically generated. You will have your own ID, and you need to take and just change this part. This is to say Google Collaboratory that we are currently going to work with our exact project under the user with which I logged in. And here is another authentication which is also needed, because without that nothing will work. I don't know how those identification differ. like the first one and this one, but we need to go through this also. And here we need to do it another way. We just like press some hello, and we copy the code, we insert the code here, and we are ready to go. Yeah, everything set up. Then, if you created a fresh Google account, Google Cloud Platform account, you need to enable some services. And as you will be the administrator of your account, then you need to you should be able to do that, to enable all those services, because you have like a lot of rights. You just need to run this thing. I already enable everything. So I don't need to run this cell, but you will probably did that. We can actually run it and see what it will say us. Probably nothing very special. Okay, finished successfully. Great when everything is successful. Then we need to install our packages. There is one thing regarding Google Colab, is that we always start with the same environment, like in a free version. And and it's quite annoying if you are working in a big project and each 12 hours or each like session reset, you need to install again all the needed packages. Here we will need just 3 packages to be installed, and then it will be one more package. But currently for pipeline development, we will need just 3 of them. Google Cloud AI Platform. AI Platform is previous name of Vertex AI. So at first Google developed AI Platform, then it renamed it into Vertex AI, probably because this name is more fancy. And currently it exists as Vertex AI, but the library still calls itself like AI Platform. So you need to understand that AI Platform and Vertex AI is actually the same, but under different names. KFP, you should already know that it's Kubeflow pipelines and Google Cloud Pipeline components. We need to install those things, and if you don't know this, just in case, to run, we are currently working with bash. So to run bash command, same as we did here in Jupyter Notebook, we need to put exclamation mark, and then we write we run our bash command, and well, we are going, everything is installing. This exclamation mark at the beginning of our command is tells our compiler that we are currently going to run some bash script, some bash part, not Python one. So don't please interpret this code as Python, because without exclamation mark, it will interpret everything as Python. And here, after everything was installed, you need to restart your runtime. We restart our runtime. You can also restart your runtime, so restart the kernel with this code. But here we can. This is needed if you, for example, run it. This notebook in some other environment, for example, locally at your local computer, or for example in Google Jupyter Lab in Vertex AI in Jupyter Lab, because there is quite different things which might or might not appear. For example, here restart pipe runtime appears, such a button for convenience. But in other places it might not appear, so there's also a code which will do exactly the same. And currently we have everything restarted, and our libraries should work properly. Then we need to set up global variables. It's a very quite annoying part, I think, but we need to do that, and we need to specify a couple of things. Most of them are like easy ones, and the most complex is service account, but it's a very important one. What we need to specify? We need to specify path. It's like just leave it as is, as I have it. We need to specify region. As I told, we will work with a region West 1 just for not to use a standard one. And also, what region depend? Why should we use different regions? Actually, Europe S1 is the closest to me, for example, and one of the closest, and it has low CPU. And sometimes they say that it will have lower latency compared to more further regions which are more far away. For example, US ones. So, but you can work in any region you want. For example, the standard one is US East, US Central, I guess. So this doesn't matter a lot. You can just leave it as is. Then we need to get project name. Also, there is a code to get our project name, and you need to just leave it as is. Then we set our bucket name. You can change the bucket name, or you can leave it as is. And we need to create a bucket. So we create a bucket name, and then we will, within this bucket, in Google Cloud Storage, we will create like for pipeline our like folder. I will then show you how it looks like in Google Cloud Storage. And then we need to specify service account, and this will be different for each of you. And how to find it? You need to go, and here is the screenshot dedicated to that. You need to go IAM. It means Identity and Access Management. I will now show you what is that. It actually codes as the same at AWS. So we have IAM. We'll wait until it will load. Okay, and we have like the first tab, and here we have Compute Engine Default Service Account, and that's exactly what you need to get. You just copy this name and insert it here. So it should have after this thing, you have developer-service-account.com, and it should work fine. So we insert service account here, and we run this cell to set up all of our environment variables, and we move further. Here we will just import all the libraries we need. We actually import quite a lot of things. What we mostly import? We import some Kubeflow pipeline parts, and it has some domain-specific language like artifacts, datasets, input, model, output, metrics, etc. So those are like parts of Kubeflow pipelines, and we will use them. Also, we from some specific things, we import compiler, and we get some imports from Google Cloud, and we mostly import AI platform and Google Cloud pipeline components. We need to run this also. Hopefully, it should work fine because we installed everything. Yeah, it already ran successfully. So we move further, and currently we can always already create a pipeline, and we will start from the very beginning, and we will create a part for data load. But first, let's take a look at our data and download it. As it's an open data, we can just download it from the URL, and we will use pandas for that. So we import pandas as PD, as we always do, and then we read our data and we'll visualize it. Actually, I already had it visualized, but let's see whether anything changed. We can review our data here, and what we will work with this quality column, and we will a little bit transform it to change our machine learning task into binary classification, because currently if we describe our quality column, we will see that there are almost 5,000 records in this data set, and this column has minimum value of equal to 3 and maximum value equal to 9. And from this column, we will create our target column to specify, like in a binary way, whether our wine is of good quality or not so good. Also, we have here the description of our columns, and what is their meaning. I don't want to spend much time on here. So we have some characteristics of wine. I'm not really a wine expert, so every time I work with this dataset, I just skip this part because, okay, we have some features, they are numerical. As we can see, all of the features are numerical, like perfect thing. We won't care about like text processing, image processing, just work with tabular data. That's the easiest thing which we can do in this life. So you can definitely explore more of those features if you're interested. And by the way, in Vertex AI, we can. They also have their own explanation tool, which works a little bit different than, for example, local Shapley values. So when you like import Shapley values library and you want to get importances of your features in Vertex AI, it will provide different results, and sometimes they are better. So there is an opportunity to get feature importance from your dataset in Vertex AI without doing anything yourself. And here we will build our first component, and it will be it will allow us to get the data. What we do here, as I already explained to you, we have here some part which most of machine learning engineers and data scientists are very acquainted with, very good acquainted. So that's something very common, but there is some specific parts. What we have in arguments, we have a URL to our dataset from which we will read our data in the same exact fashion as we did it here. So we specify just URL and delimiter for our columns because they are written in CSV through comma and a dot. Then we have such special things. We have two arguments which have type output, and in square brackets we have dataset. What does it mean? It means that we will, from this component, like some abstract thing, we will get a metadata rich like in this component we will have two outputs which store some metadata, and they will be artifacts of type dataset. So to put it more simple, it tells our component that we will have some artifacts that will be of type dataset, and by specifying that those artifacts will be of type dataset, we say that we know that this artifact will have some properties, and I will tell about those special properties in a minute. So what we do within this component, we just import all the libraries we need. We actually need them to import in each component because each component runs in a separate Docker. And we will split our data into train and test, and we will specify some parameters for split here. So we then load our data from the external source. We create our target column. We first create a best quality column, and then we say that our target will be exactly equal to best quality. And what will contain our best quality column? It will contain our quality column, but with a transformation. Oh, interesting. I didn't. So, wow. That's a functionality of Jupyter Collapse. So when you just hang at a column of your dataset, it will show you the distribution of this column. Interesting. They are always evolving, so I didn't know about this thing. And we can see the distribution. So and we say that if the value in this column is more or equal to 7, then we will put 1, and else we will put 0. We can actually specify this part by just, for example, having in this way. Probably it will be simpler to understand. So we just check whether x is more or equal to 7 and transform it to int. Then we say that our target will be this column, and we delete all the columns which are unnecessary in place. And then we have our dataset ready, and we will split it into train and test with test size 0.3. And we will write it down into some location. And what is that location? We know that our outputs from this component will be two things: dataset train and dataset test. And those outputs are actually artifacts with type dataset. And it means that those artifacts have property paths. And this path is actually the location where all the artifacts of this pipeline and this component are stored in GCP. So we just and also this this artifact will have path of where the component runs, and component runs in the same path as where the pipeline runs. And then we have Kubeflow already understands that this artifact will have name dataset train, but we also want to add .csv, and this will be the location where we store our train data. So our train data will be stored in the location where we store all the artifacts of pipeline run, plus dataset train.csv. Actually, pipeline run and component run. Yes. Can we get data from? Yes, we can. Here there is a question in chat. Can we get data from, for example, from BigQuery and write results to BigQuery? Yeah, exactly. We can get data from BigQuery and write results to BigQuery. And there are examples even in, I think, even in official Kubeflow repository. By the way, for the examples of such notebooks, you can go to, or not Kubeflow, to Vertex AI, Vertex AI GitHub. They have a lot of examples of Jupyter notebooks, and it seems to me that I saw for this topic some examples. So we are currently at the Vertex AI examples, and we want to go to official, and here we have a lot of. And here is BigQuery ML, and you can explore what they provide here. But yeah, it provides using Python and Scale to query the public data in BigQuery. So you can review how they do that. But I think that they just as everything is in one Google Cloud platform. So if you have access to BigQuery, you just need to specify like the table and create some path how you access to BigQuery, and then everything will work within component in a very similar way to how it works locally for you when you are developing a solution. The only part which is important is that you're using a service account, right? So service account, what is it needed for? When we are working in Jupyter Notebook, like now, I'm working as Hanna, but when I will run a component, the component will be run not under Hanna, but it will run under service account, under this service account, which I specified, this one. And it needs to have access to all the data which I use, and everything I use in my components. So if you want to connect to BigQuery, you just need to be sure that your service account has access to BigQuery, because it's not always so, and you just need to be prepared that you probably will need to contact your Google Cloud platform administrator. And actually, we can get data from any storage. So, for example, if we have some custom storages or some Postgres somewhere, so we can organize everything and access there from our component. But probably there will be some specifics that if it will be, for example, Postgres, some Postgres which is outside of Google Cloud Platform, we will need to store credentials in some secrets, which is a separate service of Google Cloud Platform. So, and connected here, but everything is doable. I already did that at my job. Here we are working in a more easy with a more easy example, just to understand how everything works. So we already created first component, and that's like 1/4 of our path of creating the pipeline. What we have for now, we for now got our data set, we split it into train and test, and we will download it into our Google Cloud storage. Great. Then we want to train our model, and we want to use the data which we created on the previous step. And when we will describe our pipeline, our train will go right after our get data component. Here we specify the everything is exactly the same. Like we have an like decorator component in which we specify base image. It will be again Python, but with I think here we didn't. Yeah, here we also imported scikit-learn, so we also install scikit-learn and pandas. Here, for example, we could have specified some custom image which already has Python, scikit-learn, and pandas. But for simplicity, we just don't build a custom image because it will also require some time for explanations. And also one part. Currently, we are working with very small components, so they are compact, and they can be can be compressed in one cell. But if you have a very complex data processing part and model training part, you will need to split it into several files, and actually to do that in a fashion of real Python project, not in Jupyter Notebook style. And this is also doable, but it won't be in this way. Like when we have a component decorator, we create a function, and we describe everything in a function. It will be in another way, but unfortunately, I cannot show you everything I know about Vertex AI in one speech. So I will just tell you that it is also possible. You will just need to create your files and store them locally. You will need to create a Docker, and you will need to create a YAML file in which you specify the configuration of your component, and then you just import your component from YAML file. So everything is described in your project. You have YAML file, and you import the YAML file in the component, and then use this component in the pipeline. And currently, we are just explicitly describing all the pipeline in one Jupyter Notebook, which is perfect for the first demonstration of the tool. So we will train our wine quality model, and here we will have new thing, which is input. We already had output, and we will have input. For input in this component, we will have dataset. So some artifact with the type dataset, and for output, we will have artifact with type model. What we do inside the component, we import scikit-learn, we import pandas and pickles for dumping our model, and we get data. Data we get from the path. We'll pass here some exact data when we will describe the full pipeline. And currently, we just say that we will use of each artifact of type dataset we have path, and its path will be just location of pipeline runs artifacts plus dataset, but we need to add CSV to it. Then we specify the model which we are going to use. Then we feed the model, and then we write metadata to our model, because as our output artifact has type model, it has some property metadata, and it's like dictionary, and we can specify here some custom case with custom values. So we can say that we can add a framework key to our metadata, and we will say that it's our random forest. Then we create a file name, and we dump our model. So just in an ordinary fashion, how we always dump our models in a pickle file. We can do in other ways, but the simplest way is to just dump it into pickle file, and it will be stored again in GCP. Then we will need to run this cell, don't forget it, because otherwise our pipeline won't understand what we are referencing to. Then we need to evaluate our model. We actually can skip this part, but mostly we needed to understand the performance of our model. And here, this part is, you already know it. It is the same as in the previous component, and we define the component. It will have some input data set. We will use test set. We could also we could have used both train and test set, but currently for simplicity we will just evaluate on test set. We will use model, and we will have some parameters of type string, and we will have on output also metrics and KPIs, like business KPIs, key performance indicators. And we will also output some named tuple, and just for some for diversity. So what we do within this component, we import some libraries for our help. Most of them, most important is that we import metrics to evaluate the quality of our classifier. And we again load the data. It will be test data set. We initiate our model, we then load our model. I think that this is even not needed. Then we drop from our initial dataset, because it has target, we drop target. We allocate target separately, because we then compare it with prediction, and we generate predictions. Then we get scores with we force our model to predict probabilities, not just labels 0, 1, but we predict probabilities from 0 to 1 to in case you want to specify custom threshold for our evaluation. And then we create a ROC curve, like it's a standard way to how to evaluate our machine learning model. And then we also record ROC curve to metrics, and we record confusion matrix, which is like true positives, false positive, false negatives, true negatives, which is also like things which are used for evaluation of performance of classifier. We also record that to our artifact, which is metrics. So we have such classification metrics artifact, and it understands that we can log some log curve and confusion matrix. Then we also evaluate the accuracy score, and we load our thresholds, which we got from the input. Yeah. And we write accuracy to metadata of our model. Before we wrote framework into our model, and we log some metrics into KPIs, and we create some deploy, which we then return. That is our evaluation part, and I think that it's most complex, which model metadata to use some metrics into metrics, classification metrics metadata. Then we deploy our model, and here we have quite different parameters in our decorator, component decorator. We will import Kubeflow pipelines here, and what we do here, we actually need to create an endpoint. Before that, we necessarily need to initialize like Air platform. We create an endpoint if it's at first we find out whether if it exists or not, and if doesn't, we create a new one. Then we define this function within our component, because we in this fashion we can work only with code in one cell. So we define all the functions we need within one component, and here we define like function create component, and it creates a new endpoint if we don't have any, and if not, it will return the most recent for this task, because they can be distinguished by the name, the endpoints. And then we are importing the model programmatically. It means that we could have imported it like just specifying the location of last model, but we and do that, or we could have done that in using UI, but we are importing it this way. Importing model, it means we are importing our trained model, which we stored in Pickle. We are importing it in Vertex AI, so we need to transfer our model in Pickle into a model which Vertex AI understands, and then we will have an opportunity to deploy this model to Vertex AI. Oh, not to Vertex AI, to endpoint. And after we uploaded the model to Vertex AI, we deploy it. And here you can see that we specify the model, and those are actually very standard things for model uploads. We need to specify display name. We need to specify URI, so that's a location of the model artifact in Google Cloud Storage. We specify serving container, and serving container will be like the one which we are passing here as an argument in the component. We specify the health route, predict route. That's important parts of uploading the model. Without them, and nothing will work, because that's the issue I had like recently. And then we just if we want to have some specific environment variables in our serving container, we specify them, and in our case it will be model name. Great, so we created a model here, and then we deploy it. We deploy it on a machine like very small and standard one, and we specify here endpoint, which we created. So we have model, we have endpoint, and we combine that. We place our model on this endpoint, and then the endpoint will answer with predictions from our model. It's very important to specify here traffic split. Without that, we won't be able to then get the predictions, and display name for us to have some pleasant name of our model. And we save resource name into our output param. So we have a Vertex AI model as an output artifact, and we save it here. Then we need to run this cell, and we are done with creation of our components in Vertex AI. Then we will create a unique display name of our jobs, which will run, and here I specify the display name, and we will check currently whether we have proper pipeline route, and here what I have. So in this route I will run a pipeline. I will now show you what I currently have by this route, but for this I need to enter my Google Cloud Storage. And here I will have some buckets, and in those cloud storage, I have here like this bucket, which we also have here, like Tokyo charge. This is the name of my project, and this is the name of my task bucket wine quality. So I have this bucket also here, and here I have pipeline route wine, and all of pipeline runs with this name will be stored here. So I have already one successful run, and one more pipeline run will be generated here with the display name which we specified in Notebook. So I ran that before in one timestamp, and currently we will run with our pipeline with another display name, which will be the following with another timestamp. That is just, you can actually run everything with the same timestamp. Good. So yeah, that's what we have, and we specify a pipeline. So we created all the building blocks, and we now need to combine everything in one. So we specify pipeline route, and we because it will be like the storage of all of our pipeline artifacts, and we specify like the name of pipeline. Then in pipeline itself, those are quite standard things. So we need to like we need to specify what we pass to our components. That will be like URL and some standard things like project ID, region, display name of our jobs, API endpoint, so the path to it, thresholds, dig string for our evaluation metrics, and serving container image URI, that is for our deployment part. So here you remember we had serving container image URI. We need to deploy our model on some specific container which contains everything we need for running this model. We have a scikit-learn model. For this reason we will use a standard like scikit-learn CPU scikit-learn CPU container, and it's with another version of scikit-learn, but for our training purposes it will be enough and everything should work. What we specify in our pipeline, actually it's a quite easy part. We just built everything from the blocks we created. We first use our get_wine data. Get_wine data is the first component which we created. It is located here. That's it. That is it. We already reviewed it. So I will move here back, and we use our first component. Then we use our second component for training data, and we pass the argument which we specified. We pass there only one argument in both of those components, because all the rest are artifacts of the component, and those are not like some external arguments. Those are internal artifacts of those components. If we come back here, we can see that we have only one argument, like parameter, and rest are our output artifacts, and we don't need to specify them when we are creating a component and using it in the pipeline. Then we create for evaluation. So we got data, we trained our model, and we create evaluation. And then we have a condition. You remember I showed you the like graph of our component, and there was a condition. So we might specify here. We might specify here different conditions. Either we can pass them either an argument here into component, like for example whether we want to deploy or not our model, or we can get it from some as an output from our previous components. And currently we will use the output of our previous component. If it will say that we are deploying, that it will be generated in case we don't have endpoint yet. Then we will deploy our model, and that's it. So we have get data, training, evaluation, and then conditional deployment. I ran this cell, and currently we need to compile it. Fingers crossed, everything will compile properly. Okay, everything compiled. This running is nothing very harmful. Then we need to create a run for AI platform. That's like part of working with AI platform. We always need to create a run of our Vertex AI, and we create it by running this command. So we need to call AI platform init, and then specify project and region. And then we compiled our pipeline, and by the way, we will have a JSON created here with everything. We can review it with all the details about our component. I will probably, if I will be happy, I will download and show you the contents of this file. Save. Let's view it. What it has, and yeah, that's it. So this is the I think you should see my file, yeah, because I'm sharing full screen. You should see the contents of the file. So we have like big JSON in which like that's the way how our pipeline looks, and we, for example, could have loaded our pipeline from this JSON, and Vertex AI will understand that, well, we need to run it in this way, and it will be exactly the same way which we want, which we are currently specified in our full notebook. Yeah, so it knows everything it needs to know. You can then examine it in more details, this file, because you will have it locally if you will run this all this code. So this is this one. Then we create. We already created the run. And here we create the pipeline job. So we create a pipeline job where we specify the path of file which we just compiled. So it will use my local file with all the configuration of pipeline. Here we have an argument enable caching. That means that if we, for example, experimenting and we are trying to debug our pipeline and reach the state where everything works, then it will be useful for us to have enable caching like true, because what it will give us, for example, we have several steps, let's say 5 steps in the pipeline, and we already debugged our data preparation step and it works. We don't want to wait until it works each time we are running the pipeline and trying to debug it. If nothing changed in the input parameters of this pipeline, we will just use the previous artifacts of this pipeline and and all the history of previous successful run. Yeah, so I set up enable caching true so that it optimizes us work a little bit if something won't work. What else do we use here? We specified display name and region as, again, yeah, hopefully later we'll thank you for the speech. Thanks a lot. Yeah, actually, I wanted to like to be compact and to explain everything in 2 hours, but I think that we are a little bit. We will be a little, like, I think that we will end up to in Ukraine it's currently 9, so up to 9:30 because we are finishing now. So we will now run the pipeline and it will be it from what I wanted to deliver to you. So we created a pipeline and we will start it. So it will run, and it's running, and I'm so happy all the time when everything worked, because I was a little bit nervous regarding this pipeline. Yeah. Actually, most of the part I already covered. So yeah, if you survived through all this technical information already, you really got like 90% of everything I wanted to tell you. Currently, we will just observe what's going on. After we started our pipeline, we'll have a link to monitoring of this pipeline run in our Vertex AI, and I just pressed on this link and. My pipeline opened here, and we can observe what's going on. And currently, what we have here, we have green. In green, we have all the components which are either running or already ran. And in gray, we have the pending pipelines. There is a dependency, so train will run exactly after data preparation, and one quality evaluation will run exactly after data preparation and train, and deployment will conditionally run after the evaluation. So we have such dependencies, and nothing will run before it needs to be, and before everything which is required is run successfully. So currently, what we have, we can press on our running part, and it says us that it's waiting to be job to be provisioned. It will actually take some time to provision. I think that my full component will run for 12 minutes. We can currently observe my previous successful run of the pipeline, so that I could explain you everything what will be done. So that's our running pipeline, and that is my last successful run. And I expect that this new pipeline will run same successfully as the previous one. So here we had like everything is marked as green, such green check. It means that all the components were run successfully and nothing was used from caching. So we just run everything in 12 minutes. And we also deployed our model. And here we can see like the artifacts, and we see that, for example, some information about the model and some information about the place where we deployed our endpoint. What else we can do? We can go to this endpoint, for example, and observe it. We can copy. For some reason it doesn't show to me. Probably because okay, probably because I didn't set up some rule. Okay, then let's observe what we have on GCP after a successful pipeline run. After each job run, there will be some files generated because we specified a lot of output artifacts, etc. So after get one data, we have at our Google Cloud storage, we have test dataset, train dataset, executor output, and output. And in output we have like some prediction results, and that will be generated on the evaluation step. But after just preparation step, we'll have those three files. And executor output, it will just tell you some information about your artifacts. You can then use it if you want to, or you can use it for some other tracking of your experiments part. What else do we have here? We have that's from data preparation part. Some reason I got too much back. Here, and we were here. Yeah. Then our next step is model train, and here we will also have executor output, because specifically that we want to store our output in a JSON format, and if there are some errors, we can also examine them in this output file. And we have our model, which we dumped in our code. So let's see. It's still running. It will run like for 12 minutes, and in train part we dumped our model into some pickle, and here there is exactly that pickle. Where is it? Yeah, and here is a pickle in which we dumped our model. Also, we have evaluation part, and in evaluation part we have only executor output, because all the rest of information was provided in our train part, because there is very good data. Sorry. No, not in train, in get data part. And here, if we look into our evaluation, or it's not. Sorry. It's from batch prediction. I forgot. So it's a little bit laggy. In evaluation, we have executor output, and it will contain all our metrics, which we have from our model, and we can review it. And here is some information regarding the artifact itself. That's about model. And we, if you remember, we wrote metadata about model, and that is the accuracy of model. And then we have our like metrics. That's another artifact, and we have here some confidence thresholds, and we have different values of false positive rate, and we can and recall. So this is from also from the code which we created here. Yeah, because we called drop curve and confusion matrix. Where we were here. Yeah. So after we generated those metrics file, we can either use it for visualization in some dashboard, or we can also instead of creation this JSON file, we can visualize the results of our experiments in the Vertex AI experiment part, and it will be like more usual. Or we can use it in ML Flow if you're using it for like or weights and biases, which is a tool for experiments tracking. Anything you want, or you probably want to write some script which will visualize like different performance metrics from different experiments just in Jupyter Notebook, and just like run through all of such files in all experiments, and visualize what you want. Yeah, let's see what's going on in our pipeline. I will close some tabs because I already got lost a little bit in them. So what we have here, let's go to our pipeline and see whether it's still running, and on which step is it. Oh, we are almost there. Could you please repeat about deploy condition? If we skip evaluation step, it can be just kind of flag deploy or not deploy. Yeah, exactly. There is a question in the chat, so let's see what everything is described in code, and what else I would say. But those conditions are also convenient when you want to, for example, create hyperparameter tuning. You sometimes want to train your model without hyperparameter tuning because you already know the hyperparameters, or you want to run hyperparameter tuning and you also want to create this some conditional part of a pipeline. What we write in our deploy part, we have create endpoint, and we have here like which endpoint we will create. If we already have an endpoint with this display name, then we will create the already existing endpoint. And if not, we will create the new one, like with this platform endpoint create. Then we let me check one thing, because I just understood that probably I'm missing something. Let me check. Here we have. We are going from model evaluation. Yeah. I started to explain another thing, and currently understood that I started in the wrong way. In our evaluation, we have a couple of metrics, and we have threshold check. We specified here a function which will check the condition. We have our two values, which will be our accuracy, like the metrics which we got, accuracy score between target and our predictions. Not the best decision for classification, but that's just for example. So we evaluated some metrics, and we want to create a condition whether we want to deploy this model or not. We will deploy this model only if our accuracy is higher than some threshold, and we pass this threshold in here, threshold dictionary string, and this threshold is 0.8, as we saw in pipeline parameters. Let me go to the pipeline, and I will show you this parameter. Here is it. Here is our threshold. So we could have stored this threshold in some file in GCP, but we stored it just in string in such a format like JSON-like in here. So to wrap up, we have some condition on which we will deploy or not. We could have specified this to, for example, depending on another metrics, let's say F1 score or false positive score. If we reach more than, let's say, 0.5 of F1 score, then we deploy a model. If not, then we don't need to spend time to deploy the model. Actually, model deployment is the slowest step, as you can see. So we already passed everything except for deployment. And it's always so because it needs to um, to up a lot of resources, and it takes some time. So currently, as our model is good and it has some good accuracy, which is higher than our threshold, then we are deploying it. And let's see how much time is already running, or probably it will be not here. It will be in Vertex AI, because I want you to also show the part with automation, but we'll see whether we will have time for that. And we have our pipelines, and let's see how much does it seems like our pipeline is almost done if we reference to the previous run. So hopefully it will deploy. Oh yeah, it's done. So our pipeline successfully ran, and our job ended. And currently, if we go here, we can see that pipeline job run completed, and our cell stopped running. So it finished running. Great. Then we can list our models. Before I had such models, and currently I will have two, but different. And the last, yeah, and currently I will have like one of those model is the one generated in this new pipeline. And how we can find out which one we have here. We have here probably model parameter should be somewhere, and let's see, can find quickly this part. Probably will reach here somewhere, but we definitely can find the which model ID is referring to our job. I just forgot the fastest way to do that. If we want to schedule our pipeline run, so it will do everything we described here. And if we want to run it like periodically on some schedule, we can create it in we can set up it in the following way. So we create a platform client and create schedule from job spec, and here we specify again our JSON, which we generated and which is locally located here in our after we compile the pipeline. Then we set up schedule in a cron style. So that's, if you Google like cron style schedule specification, you will find how it works. It's like quite specific if you don't used it before, but in this case it specifies that we'll run everything on Monday. If our like scheduler understands that the first day of week is Sunday. We specify the time zone in which we will run the job. We specify parameter values, which will be only the display name. So we will name how we will name our jobs, and pipeline route. So the place where all the artifacts of pipeline will be stored in Google Cloud storage. We can run that, but I think that it might require too much time. So I would go to endpoint to predictions with endpoint, and this will run before the Q&A, so that it ran and I was answering your questions. So we deployed a model onto the endpoint, and we can reference this endpoint. Where we can find this endpoint? We can go to Vertex AI and endpoints, and we can see currently two endpoints. One was created for me like as a backup in case something went wrong, and we can see here that this is the this is probably the latest, yes, because currently we have much. No, this is the latest because we currently are at 8:18, and here is the ID of this endpoint, and we can we can review which model is deployed here, and we can actually deploy another model here. So this is just endpoint. We can deploy anything here, but currently we deployed here our model because we executed the code which we executed. So to call the proper endpoint, we need to specify its ID, but here I provided code to get the ID automatically, and to test our endpoint, we need to generate some instances. And here is the code to how we can get data from Google Cloud platform. It's not very like you need to know something for that. We need to install this library GCSFS. This means Google Cloud Storage file system, and we need to create a file system variable and open our test data set in such a way, like with file system open, we here create read bytes and like read data with pandas. Let's allocate our data path in a separate variable so that it was more manageable, because currently it's like too long. Data path, and here I actually specified the old data path. Let's find out where our data from this run will be stored, and they will be stored dataset train here. So and actually we're interested in test. So this is where our dataset test will be stored. If we press here, we will get exactly two dataset test. It's again doing something strange, but probably it will. That's because we renamed the name with this file and added .csv. Probably that's because the link doesn't work. So the link to artifact. So we have dataset test here, and we can just copy URI and set and insert it here to reference the correct test set. So we created our past data, and we want to read 10 rows of our data on which we will then predict. Then we transform it in a form of a list of lists, and it will be in such a form, and that's what we will pass to the endpoint to predict the values for us. Then we specify the endpoint name, and we find out the endpoint ID. Let me show you what this will generate. So this code will just take all the endpoints which we have and find out the latest one. And here we need to specify, for some reason, the region once more, or not. That's because I ran it in a wrong way. That's because I ran it like from the beginning of the cell, and it thought that I'm going to use just command line. Again, okay, let's specify here that we want to use Europe West 1, and enter the value between 1. It will be 14. And everything disappeared. Where it is? It is because I deleted probably the cell, and it failed to, or not. That's because it's executed and it didn't output anything. Okay, and let's see what it provided us. Endpoint ID. It doesn't. It does to make this default. As I expected, something started to not work. Okay, let's just specify the endpoint ID here, like manually. We will use our latest endpoint. This code should work and provide us the latest endpoint ID. Probably I will debug it and upload the updated version. We can currently comment it out. And here we will again init our platform. Actually, we already needed it. We can comment it out and create endpoint and predict for our instances. Let's see what we've done. Okay, it worked. And we can see our predictions. Here are our predictions from the model. And we can compare our predictions with the actual values. And we can see that the model predicts pretty much accurate. Actually, predictions look in this way. That's a prediction object, and we just can reach the list of predictions in this way. So the list of predictions will be of same size as the number of instances which we passed. We passed 10 instances, we have 10 predictions, and we got like quite accurate performance. Great. Then we could have also done some batch prediction, but we don't have time, and it really takes some time to run. So I leave code here for you to try. And here we have one more important part. We need to clean everything. So we created some resources on our GCP, some pipeline, etc., etc. And I will currently show you how to delete my previous experiments, so that one experiment I still have. So you can do that programmatically to clean up everything. So clean up some GCP, all the GCP resources, or you can do everything manually. To do manually, you just find your pipeline and you just delete it. And it will free up all the resources used. So you delete it and it disappears from deleted pipeline. It lags a little bit, yes. And then you need to delete an endpoint, because when it's up, it can generate some costs. And to delete an endpoint, we can at first undeploy the model from it. We go to the endpoint, we go to the model, we undeploy it, version detail, no, deploy and test probably, yes. And we undeploy the model, because without that we won't be able to delete the endpoint. We go back, and currently we see that our model one is deployed and one is not deployed, and we can now delete the one which is not deployed. We can delete it, or we can deploy it on another endpoint if we want. And here we can also see that there is one ready and one active. So ready, it means that there is no models, but this endpoint is ready. We can just delete endpoint not to run into additional costs. And we can also delete metadata. Here we can just specify everything and delete everything if you want to clean up the space completely. To delete everything in Google Cloud Storage, we go to our root, to our experiment which we recently ran. It was probably this. This one was the first one, and this one I guess was the second one. And we can just delete the folder by. I think that it won't work in this way, or it will. Oh no, it should work. Just it contains some other. Yeah, it works. So quite easy, and I really recommend you to delete everything which is unnecessary, because if it's your personal Google account, you're probably really interested in reducing the costs. And that's it. If I want to get predictions, there is a question. If I want to get predictions when new data is coming, should I leave everything or can delete something? Great question. If you want to, you can delete pipeline, because you don't need pipeline. If you just want to train the model once, and that's it. Like pipeline run, that was the first the first thing which I deleted. So this part you can definitely delete. You just need to leave model and endpoint. So you leave model, which will be in model registry here, like I currently left, and endpoint, which will be here. And definitely, like if you don't delete model, then you the metadata of this model should be alive. Yeah, and everything else can be deleted. Yeah. So that's it from what I wanted to deliver to you. I will probably a little bit clean the notebook, because during my presentation I saw some drawbacks, and I will fix them for cleanliness, and I will just update it in GitHub, and you can clone my repo, or just upload the Jupyter Notebook in Collaboratory and experiment as much as you want. What we did today, we recalled about the life cycle of any ML model, and we found out about Vertex AI and how it can be useful for different roles. We found out about Kubeflow and how it is connected to Vertex AI. And we built a working ML pipeline from scratch. We also scheduled it and tested the endpoint. We didn't schedule it, and that's a good reminder that we need to schedule it. The last thing I wanted to show you is how to schedule endpoint. So we already discussed this part. I will just run it, and it will run for some time. This time it was quickly. Let me show you where you can check whether your model is scheduled. We go to, as our warning says, we go to cloud scheduler. Not warning, but command. We go to cloud scheduler. Yeah. And we will see here that we have some scheduled jobs. Currently, it is scheduled on a weekly basis, and here is our job, which we created right now. And it says that it hasn't run yet, and it will run in some region and state, and it is enabled. We can disable it, and there are some details which you can get if you like go here. You can actually change the frequency here, or you can update some other configurations if you want. So really easy to schedule your your pipeline, and you don't need to organize any airflow or some manual cron jobs setup. Just use cloud scheduler of Google Cloud, and that's it. Yeah. So we are great for now, and that's really tremendous work which we did. Let's thank ourselves for the fruitful work, and I'm really proud of everyone who was with me during all this lecture. It was really, like, I think that it's quite technical but very informative.